The modern technology industry operates on a singular assumption: social platforms must be engineered to scale infinitely. But this contradicts human biology and evolutionary constraints. The anthropologist Robin Dunbar established that the human brain has a hardwired cognitive cap on its social processing capacity. That biological ceiling limits an individual to maintaining approximately 150 stable relationships at any given time. Pushing past that number degrades emotional intimacy across a network and creates severe cognitive overload. To design software that supports relational wellness, engineers have to hard code these biological limitations directly into the product's architecture. We can examine how this architectural shift functions in practice by looking at the application DunbarrioSolo. Look at this interface schema. The application rejects standard engagement mechanics, removing public follower counts, algorithmic feeds, and ad boxes. Stripping away the pressure of infinite scale pivots the user's objective. The goal moves from gathering a broadcast audience toward tending a private network. Designing software for genuine human connection requires treating our cognitive limits as strict structural boundaries. A 2024 Royal Society study demonstrated human social networks do not scale randomly. They organize into strict concentric layers. The innermost layer, the core, holds approximately 5 people. The scaling math is highly consistent, with a factor of 3 expansion ratio between each adjacent layer. Moving outward into these wider rings, the emotional intimacy between individuals steadily drops. The frequency of contact follows the exact same downward trajectory. This mathematical scaling produces a theoretical upper boundary of roughly 150 total contacts. Human social capacity operates as a stratified pyramid with strict upper limits, not a flat, infinitely expandable grid. A March 2025 study in PLOS One analyzed how individuals actually distribute their emotional care across these network tiers. Participants consistently operated on a lay theory of their own relationships, distinguishing who belonged in their core versus the periphery. But the researchers identified a major disconnect. Structural capacity does not dictate energy distribution. Relational care allocation is highly heterogeneous. The emotional energy that people spend on different connections is surprisingly asymmetric. There is no universal, one-size-fits-all model for distributing human connection. A specific anomaly emerged in the middle layers, the 5 to 15 contact range. People frequently pour a disproportionate amount of their total relational energy into this underexplored tier. To be effective, software must map exactly where this care dynamically flows, rather than simply cataloging who sits in the static network. This diagram breaks down exactly how DunbarrioSolo translates Dunbar's mathematical models into concrete UI constraints. On the application's base tier, users are restricted to organizing their network into just 3 circles. This forced scarcity requires the user to evaluate and prioritize their immediate core connections before expanding outward. At its maximum expansion, the deep end tier permits a total of 16 circles. With each circle holding up to 9 members, the architecture sets a physical limit of 144 relationship slots. That cap of 144 lands securely within Dunbar's predicted cognitive limit of 150. By enforcing a mathematical ceiling through the interface, the system structurally prevents user cognitive overload. To capture the uneven energy distribution identified in the PLOS One research, the app relies on a feature called the ledger. The ledger's purpose is to track the invisible acts of care directed at different members across the user's circles. Looking at this interface panel, the primary tracking tool is an activity heat map. The heat signature tracks the precise density of the user's emotional energy flow over a rolling 12-week period. It compiles data automatically from app sessions and writing streaks, while also incorporating manual entries for out-of-app connection events. As seen on the manual entry screen, a user specifies the exact circle member they interacted with and logs the action taken. This creates an empirical mirror that allows a user to compare their intuitive lay theory with their recorded habits. Making care empirically visible provides the necessary foundation for a psychological intervention. By imposing strict UI constraints, the architecture is designed to redirect user energy towards specific targeted connections. This alignment matrix summarizes how the application translates academic theory into product mechanics. The circle architecture aligns with both Dunbar's network theories and the empirical findings on energy allocation, but a constrained model requires an environment of total psychological safety to function. This schematic details the platform's private by default framework. Relational practice cannot happen honestly if the user suspects their inputs are being watched, broadcast, or monetized. Traditional social graphs force user data into public, performative feeds. By combining the 144-person limit with a secure tracking ledger, a user can evaluate their social habits entirely independent of an audience. When software thoroughly respects the biological limits of the human brain, it ceases to be a social network. Relational wellness requires friction, distinct boundaries, and measurable practice. It cannot survive in an architecture engineered for infinite scale.